Hello dear students. In the previous session we have studied motion of a car on a horizontal circular level road, and we calculated the maximum velocity with which a car can take a turn. So that maximum velocity was mu rg. The equation was square root of mu rg. Now in today's class we are going to derive an expression for maximum speed with which a car can take a turn in a banked road. Okay, banked road means if the if the road has got some angle of banking like this. Okay, say if the car is taking a turn in a road like this, so you might have seen a well of death. Okay, some angle of inclination will be there. Okay, road is actually like this. Okay, if the road is like this, how the car moves and what is the maximum speed with which a car can take a turn. Okay, so that equation we are going to derive. Okay, motion of a car on a banked road. Okay, so let us consider a banked road. Say the angle of banking, let it be theta. Okay, angle of banking is theta. Angle of banking is theta. And say here there is a car. This is the car. Okay, observe carefully. Okay, you have to draw the diagram also along with me. You can pause the video in between if I'm going faster. See, mg always acts downwards. There is no doubt. Mg always acts downwards. Okay. What about the direction of normal reaction? Normal reaction is always perpendicular to the surface of contact. This is the direction of normal reaction. Okay. Now, in the previous derivations, we have seen that this angle is theta, correct now? So therefore, this angle also will be equal to theta. Okay. If you are not convinced why this angle is theta, you have to go back to inclined plane, acceleration of a block on an inclined plane derivation. Or easily we can understand like this. Say this is the surface. This is the normal reaction. Direction of normal reaction is up. If you give an inclination of 30 degree to this horizontal surface, this normal reaction also rotate by 30 degree. Can you understand? If you rotate this surface by 30 degree, normal reaction also rotates 30 degree. If you rotate this surface by 90 degree, normal reaction also rotates by 90 degree. So therefore, see, if you rotate this by theta, normal reaction also should go through an angle theta, correct now? So that is why this angle is theta. Okay. Then what is the vertical component of normal reaction? This is n cos theta. Hope you can understand, because for this theta, this is adjacent side. Here you have 90 degree, correct now? For this theta, this side is opposite side, so therefore it will be n sin theta, or here this vector is equal to n sin theta. And now what happens? See, this is the car. This is the car. If the car is moving very fast on a banked road like this, okay, now because of centrifugal reaction, car is being thrown outwards. Car wants to go in that direction, outwards, in that direction. Therefore, friction will be in the opposite direction, correct now? Because if you place a block and if you apply a force in this direction, frictional force will be in the opposite direction, because we have seen from the definition of friction that it is a opposing force. Okay. Now car is moving like this in an inclined plane. Okay. Hope you can understand. Try to visualize. So this is the road. Road is like this. Okay, inclined road. Car is moving like this. It moves in a circular path. Okay. Direction of centrifugal reaction is outwards. So car wants to go away like this. okay, because of centrifugal reaction. So therefore, what is the direction of friction? Direction of friction is downwards, down the inclined plane. So therefore, a frictional force acts here. Okay, a frictional force acts here. In this direction, frictional force will be in this direction. This is the direction of frictional force. Yeah, this is the direction of frictional force. This is force of friction. Okay, F. Now this force of friction has got two components. One is vertical component and the other is horizontal component. Okay. See, if this angle is theta, this angle also will be equal to theta. Hope you can understand. This line and this line, they are parallel. And this is the bisector. Okay. See, if this angle is theta, this angle also will be equal to theta. Hope you can understand. Okay. If there are two parallel lines like this, then this angle will be equal to this angle. Those two angles are called, remember, try to remember. Okay, you studied this in high school. Yeah. Now, if this angle is theta, this is the opposite side, correct? Na? This is the opposite side. Opposite side will be therefore f sine theta. If this is f sine theta, this is also f sine theta. So this vector here is f sine theta. F sine theta. Okay, if this, yeah, okay, then if this angle is theta, this is adjacent side, na? So this will be f cos theta. Now, see, this is the road, banked road. Car is moving like this. Where is the center of the circular path? Car is moving like this. Here there is a center of the circular path, here. So centripetal force will be in this direction. Okay. So therefore, these two forces, n sine theta and f cos theta, are responsible for centripetal force. Okay. And this car is not going up or it is not going down. So therefore, upward forces is equal to downward force. So we can write two equations here. This is very important. If you write these two equations, then derivation is over. Okay. What is that equation? One is upward force here, n cos theta is equal to downward forces, mg plus f sine theta. Mg plus f sine theta. Okay, this is my equation number 1. Okay, then second equation, n sine theta and f cos theta are responsible for centripetal force. Okay, when a car is moving in a horizontal road, okay, only frictional force was responsible for centripetal force. Now what happened? You gave some inclination. Now, component of normal reaction also is helping centripetal force. See, n sine theta comes into the picture. Okay, otherwise what happens in the case of level road? Normal reaction is upward. Normal reaction is not contributing to the centripetal force. But what happened now? Normal reaction is trying to give contribution to the centripetal force. Okay, so n sine theta plus f cos theta will be equal to centripetal force. mv square by r. What is the equation for centripetal force? mv square by r is equal to n sine theta plus f cos theta. N sine theta plus f cos theta. So using these two equations, I am going to do the derivation. Okay. Now, okay, I'll write these two equations in the next page. Okay, what is the first equation? n cos theta equal to mg plus f sine theta. Okay, n cos theta is equal to mg plus f sine theta. This is my equation number 1. Now what I'll do? I'll substitute for this f. What is the maximum value of friction? Okay, that is limiting friction. What is the equation for limiting friction? Mu into n, correct now? What happens? N cos theta is equal to mg plus mu into n into sin theta. Or this mu n sin theta, I'll bring it here, and n I'll take it common. Okay, cos theta minus mu sin theta equal to mg. Now n equal to, normal reaction n is equal to mg divided by cos theta minus mu sin theta. Okay, so from equation number 1 I wrote an equation for n. Okay, what was the second equation? mv square by r centripetal force is equal to n sin theta plus f cos theta. Okay, mv square by r is equal to n sin theta plus f cos theta. Okay, here also I'll substitute for f. When I substitute for f, mu into n, in the place of f, I'll substitute maximum value of friction. Corresponding to that maximum value of friction, the corresponding velocity will be maximum. Correct now? So therefore, m into, because when the friction is maximum, the speed with which you can take a turn in a car, in a banked road, will be maximum. M into v maximum whole square divided by r is equal to n sin theta plus f means what? Mu into n cos theta. Correct now? Now what I can do? I can take n common, n into sin theta plus mu cos theta. Sin theta plus mu cos theta. Now what I'll do? I'll make a substitution for n. Okay. Now what happens? Vm square divided by r is equal to, what is n? N means mg divided by cos theta minus mu sin theta. Cos theta minus mu sin theta. So I have written the value of n. Then what is there here? Sin theta plus mu cos theta. Now what happens? This m and m gets cancelled. R will come and sits here. Okay. So I'll write it in the next page, this equation. Vm square equal to, R will go here, Rg into Vm square is equal to Rg into sin theta plus mu cos theta, sin theta plus mu cos theta divided by cos theta minus mu sin theta. Cos theta minus mu sin theta. Cos theta minus mu sin theta. Now what happens if I divide the entire equation by tan theta? If I divide the entire equation by cos theta, what happens? Vm square by cos theta equal to Rg by cos theta. Cos theta gets cancelled. Then sin theta by cos theta. What happens? Vm square is equal to Rg into, what is sin theta by cos theta? Sin theta by cos theta is tan theta. What I am doing? Dividing entire equation by cos theta. Okay. Plus mu cos theta by cos theta, mu divided by cos theta by cos theta 1 minus mu into sin theta by cos theta, tan theta, mu tan theta. So I got one equation for Vm square, or maximum velocity with which you can take a turn on a banked road, is equal to square root of Rg into mu plus tan theta divided by 1 minus mu tan theta, mu plus tan theta divided by 1 minus mu tan theta. So this is the maximum velocity with which you can take a turn on a banked road. The derivation is over. Now, special case. If friction is absent, means if you consider a frictionless surface, then what happens? Then mu is 0, correct na? Mu is 0. If mu is 0, then what will be the equation for V maximum? V maximum equal to square root of mu is 0. Okay, mu is 0. In the numerator you have got Rg into 0, Rg into tan theta, Rg tan theta divided by 1 minus mu is 0, 0 into tan theta is 0. This is 1 in the denominator. Okay, so therefore that V will be equal to Rg tan theta. That velocity we call it as optimum speed. What does it mean? See, if you remember, when a car moves on a circular level road, okay, maximum speed equal to mu Rg. So this was the equation. Now here, if friction is absent, if friction is equal to 0, what does it mean? Mu is equal to 0. If mu is equal to 0, Vm is equal to 0. What does it mean? In the case of a circular level road, if friction is absent, maximum speed with which you can take a turn is 0. Means you cannot take a turn in the case of level road. But in the case of banked road, this is the equation for maximum velocity. Important thing is, even if the friction is 0, even if the friction is 0, there is a value for maximum velocity with which you can take a turn. Means you can take a turn in a banked road even if the friction is 0. Okay, that velocity we call it as optimum speed. At this optimum speed, wear and tear of tires is very very less. Okay, energy consumption is very very minimum. Hope you can understand the derivation. So understanding the diagram is very 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 important. Okay, mg always acts downwards. Normal reaction is parallel to the surface of the perpendicular to the surface of contact. So this is n cos theta. Okay, so since the car is moving like this, okay, in a banked road, okay, car is being thrown outwards, so therefore frictional force acts in this direction. You resolve the frictional force. Then what you have to do, writing these two equations is very very important. Once you write these two equations, then the remaining thing is simplification. How to write this equation? Upward force equal to downward forces, n cos theta equal to mg plus f sin theta. Okay, then so these two forces, n sin theta and f cos theta, are responsible for centripetal force. So therefore mv square by r equal to f cos theta plus n sin theta. By simplifying this equation, you write an equation for n, then that n you substitute here. Okay, so we wrote this equation number 1, we have simplified for n, we wrote one equation for n. Then what happened? The moment I substituted okay, F equal to mu into n, maximum value of static friction. When the friction is maximum, the speed with which you can take a turn is maximum. Then I have substituted in the place of V, I have written Vm. Okay, then the remaining things are just substitutions. Then we got an equation for maximum speed. So that is square root of Rg into mu plus tan theta divided by 1 minus mu tan theta. Now here, the special case, if the friction is 0, then mu is 0. Even when mu is 0, you get an equation, something called Rg tan theta. What does it mean? Even if the friction is 0, you can take a turn in a banked road. Whereas in the case of circular level road, this was the equation for maximum speed, wherein we have seen that if mu is 0, maximum speed with which you can take a turn is 0. That means in the case of a level road, you cannot take a turn if there is no friction. Okay, hope you understood. So this derivation is a little difficult. You will have to resolve the vectors 2-3 times, practice. Okay, then only you will be comfortable with this derivation. You do this 2-3 times. Okay, hope you have understood this. Thank you very much.